Steel is the most widely used material for reinforcing concrete elements. The two materials bind together without any slippage and thus act together as a single unit in resisting the applied loads and adding to the tensile strength of the concrete. In this lecture, I am going to discuss how to calculate the diameter and the number of steel bars required for an RCC column. The diameter and the number of steel bars depends on the size of the column, its load carrying capacity, and the grades of steel and concrete used. For illustration, let's quote an example in this regard. Suppose we need to calculate the diameter and the number of steel bars required for a column of size 300 mm into 300 mm, which is carrying an ultimate axial load of 950 kN, and the grades of concrete and steel used are M20 and Fe415 respectively. The gross area of this column, that is area of cross section, will be equal to 300 mm into 300 mm, and the total will be 90,000 mm square. As we know, AG is equal to ASC plus AC, where ASC is the area of steel and AC is the area of concrete. Or we can simply write it as AC equal to AG minus ASC. To calculate the main reinforcement, we can use the formula PU equal to 0.4 FCK plus 0.67 Fy ASC, where PU is the ultimate axial load of the column, which is given as 950 kN or 950 into 10 raised power 3 Newton. FCK is the grade of concrete, which is given as 20. AC is the area of concrete. Fy is given as 415 and ASC is the area of steel. By putting these values in this equation, we get 950 into 10 raised power 3 equal to 0.4 FCK, which is given as 20, into AC, which is equal to AG minus ASC, plus 0.67 Fy, which is given as 415, and writing ASC as such. After putting the value of AG equal to 90,000 mm square, we get the value of ASC equal to 852 mm square, which is the required area of steel. Let's provide the minimum size of bar as specified in IS code, that is 12 mm. Area of one bar will be equal to pi by 4 d square, which will be equal to 113.1 mm square. Number of bars will be equal to ASC upon area of one bar. On substituting these values, number of bars will be 7.5, say 8 bars. Again, ASC provided will be equal to number of bars into area of one bar. Number of bars is calculated as 8. Area of one bar is 113.1 mm square. On substituting these values, area of steel provided will be equal to 905 mm square, which is the actual area of steel. Now, we need to determine two things, that is diameter of the lateral ties and the pitch or simply the center to center distance between the lateral ties. The diameter of the lateral ties shall not be less than 1/4 of the diameter of the largest longitudinal bar and in no case less than 5 mm. That is, diameter of ties will be equal to 1/4 into 12, which will be equal to 3 mm, or we can take 5 mm, whichever is greater. Let's provide 6 mm dia bars. The pitch of the lateral ties shall not be more than the least of the following. The first one is the least lateral dimension, that is 300 mm. The second condition is 16 times the smallest diameter of the longitudinal reinforcement bar to be tied, that is 16 into 12, which will be 192 mm. The third condition is 300 mm. So we have to provide the least of the above three conditions, that is 192 mm. Hence provide 192 mm center to center spacing. So this was all about this lecture. If you like my content and want to read more about it, you can check out the compiled PDFs from my website. The link will be provided in the description box of this video. Thank you.